As built for AutoCAD. Tutorial, Tank Analysis. After this tutorial, you will be able to define point cloud sections, fit a cylinder, run a tank analysis, create various visual reports, and import the volume table to Excel. On the As-Built Modeler ribbon, click Define Circular Shell command from the Sections area. Click 3 points around the diameter of the tank area. This is a quick way to isolate the points on the tank area itself. Orbit to a better view and click Define Rectangular command from the Sections area. Select the desired area and run an analysis on this section of the point cloud. Here's how. Click the Fit Cylinder using Visible Points command from the modeling group. Notice that we have the cylinder fit to the points in the best fit configuration. From the As-Built Analysis ribbon, click the Analyze Cylindrical Part of a Point Cloud command from the Analysis group. Click Select Cylinder, pick to highlight the cylinder created in the previous step. Now we will choose a slitting point. It can be anywhere in the point cloud. This is the location to cut the cylinder open to unwrap the points. Click Settings. Set the parameters as shown here. The distance value, greater than 0, will be 2 inches above or below the surface of the cylinder. The exaggerated scale lets you place an exaggeration so you can visually see where the challenging areas are located. For this tutorial, set it to 1, no exaggeration. The grid size gives you an overall view of the plus-minus deviation values on the entire cylinder. It defines the resolution of the deviation analysis. Large grid size, low resolution, fast computation time. Small grid size, high resolution, but longer computation time. For this tutorial, set it to 12 inches. Click OK. On the results area, verify that the correct options are picked. Here, you can also change the name of the project and its destination. Click Start to begin the analysis. The speed of the video has been altered for demonstration purposes only. Now we will create a colorized point cloud and unwrap it to be able to look at the surface. Ensure that the parameters on the boundaries of visualization area are as desired. On the Color Scheme area, click the Edit drop-down and select New Color Gradient. Now we have a value of +2 and a value of -2. To create the point cloud, click the Automatic Generation of Name. Ensure that the box for Unload Existing Point Cloud is selected. Click Start. The speed of the video has been altered for demonstration purposes only. Here are the results from the analysis. You can see the best fit cylinder that we created for analysis. We also have a 3D solid. The 3D solid was constructed by using a grid with points extracted every 12 inches square through the point cloud, just as we specify in the earlier settings. To see the point cloud that was generated, select Top View and zoom in. Under Section Manager, uncheck Current to turn off the point cloud. As requested on the previous settings, here we can see 2 things: Polyline's grid with deviations and the grid size with 12-inch centers. Notice that at every intersection we have the plus or minus deviation value based on its location compared to the ideal cylinder shell. In this example, it sits 1/8 inch above the surface and -3/16 below the surface. This is the indication our highest point, which is 2 inches above, and this indicates our lowest point, which is -1 and 5/8 below the cylinder. We also created an unwrapped point cloud based on the colorized legend that we selected. Under Section Manager, select Current to turn on the point cloud. To show the legend, highlight Current by selecting it and click the Create Legend icon. In the Create Legend dialog, you can see that it uses the +2 and -2, which we use to colorize the point cloud. Change the text height to 8 inches, click OK, and place the legend on the point cloud. Here we see the upper bound, plus, and lower bound, minus. The gradients cover all the points in the analyzed point cloud. When you zoom in, you can see the corresponding color that is reflected by the legend and the heat map for the unwrapped point cloud. In addition, a table was created that can be imported to Excel. To do so, open a new Excel sheet. Click the Data tab from Text CVS and select the tank analysis table file. Click Import. Ensure that you have semicolon as your delimiter. Click Load. Once it loads, you can see the analysis data, the deviation values per row and column of the grid visible in the drawing, as well as the consecutive volume at defined elevations. The table can be used to derive the tank analysis report. In this tutorial, you learned how to define point cloud sections, fit a cylinder, run a tank analysis, create various visual reports, and import the volume table to Excel.